forever.
Today, so there was like this whole week just called.
I had a question. Was the recording right before it said go?
No.
Beautiful.
Maybe it was.
Fingers crossed it was.
Yeah, I don't care. All right.
Let's add Caitlin. She'll be watching.
Yes.
Hey, Kate.
Yep. Perfect. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14. Yeah. So she's the only one who's gone. Perfect. So today we are finishing 4.7, and we are going to review after we finish 4.7. So if you look at your lesson plan, I know it only says collect 4.1, but you also are going to collect 4.7. So the reason it says this is because last year I made it into one assignment. I just split it into two, even though it was only one assignment for students last year. So all the odds, the solutions are in the back. So my expectation is you're checking them as you go along. So just like in class, on quizzes, on tests, and homework, you must blank your blank. Show your work. Okay. I need someone to bring me a record player. Because this is a broken record. I keep telling you, show your work, show your work. I'm done asking you to show your work. You gotta just do it. Graphs must be on graph paper. This was on the lesson plan. This is on the homework rubric. I told you this in class. How many points do you get if it's not graph paper?
0.
0. Okay, being very clear.
I know that from experience.
So this assignment that I'm going to collect tomorrow is all about graphing. It must be on graph paper. Okay, cool.
I don't
Perfect.
own graph paper personally.
Do you want me to get you some?
I think I have some.
Okay, cool. Got it. All right, so dilation. We are on the top of page 12. We're going to finish 4.7 today.
Sweet.
Cool. Does everyone have your notes out?
Yeah.
Okay, so dilation. Dilation is we're going to focus just on the vertically stretched and vertically compressed. So when I say dilation, I'm just talking about the stretching and compressing of the graph. That's the fill in the blank. Stretching and compressing of the graph. Stretching and compressing the graph. So top of page 12. So there are two types of dilation. So just so we can be clear, we're only going to deal with dilations as vertical, because although you could have a horizontal compression, I only want there to be one correct answer when I'm asking you on a test or quiz. So therefore, we're only going to talk about it vertically. So two types of dilation. You either can have a vertical stretch or a vertical compression. Those are the two fill in the blanks. Either a vertical stretch and you could have a vertical compression. Those are the two we're going to be using. Okay. So before we even graph this on our calculator, we need to know what it's going to look like. But you already know what it's going to look like. Thank you, Chapter 2. We studied absolute value. If I have a number between 0 and 1 in front of my absolute value, what's happening to it? It gets wider. If you have a number greater than 1 in front of your absolute value, like 3, what happens? It gets narrower. So you already know what's going to happen here. So what does x squared look like? It's a parabola. It's a u. If I have a number between 0 and 1, for instance, a third, what's going to happen in a parabola? It's going to widen out. Beautiful. No graph needed. You already intuitively understand what it's going to look like. So go ahead and plot. Do I want to put it on our calculator? No, we don't need it on our calculator. We're fine. But for this one, we are going to put the parent graph just for more practice. We're going to practice putting the parent graph of x squared so we can compare it and see what's happening. We know what's going to happen, just proving it to you.
We use calculators on the quiz.
No.
What?
No, this was communicated to you last class. On the top of the practice quiz, it says no calculator. Because I'm not interested if your calculator can calculate it and graph it. I'm interested if you can. And notice, we're not using a calculator when we're about to graph it. So the points we're going to plug in, my x values are -2, -1, 0, 1, and 2. What would the y value be for Negative 2. What's negative 2 squared?
4.
4. What's negative 1 squared?
1.
1. 0 squared?
0.
0. 1 squared?
1.
2 squared?
4.
4. Awesome. So these are the points we're going to use. These are the parent functions. This is where you start. Then we're going to transform them, whether that is a translation, moving it side to side, up and down. Maybe it's a reflection, so I'm going to take the points and flip it across the x-axis.
Right.
Or here, we're going to have a dilation. So we're going to
Widen it.
compress vertically. So if you're like pushing down, it's kind of like if you're pushing down on my arms, they get wider. So it's going to be a vertical compression. We already know what's going to happen is a vertical compression.
But why do we know that?
So 1/3 in
Yeah.
front, we know it's going to be wider. So it's kind of like if you took it and
Like,
compressed
you
it vertical.
and it gets one.
Yeah, so already have your arms like this.
And then
And if I press down your arms, it's going to go down.
like
So it's going to get
push
wider.
something and it goes like that.
Yep.
I
It's
got
gonna,
you. I
Mhm.
got you.
All right, so this is vertically compressed. And it gets wider. Yep. Less than 1 and before the x.
If I write just like,
Decimals?
wait, are we gonna have
Compressed.
like what
vertically.
happened on the quiz?
We're gonna go over practice quiz as soon as we're done with the lesson. Yeah.
Decimals also?
Yeah. So I could put like 0.2. That is between 0 and 1. Yeah. Okay. So we know what it's gonna look like. Let's plot our parent function. So I have a point 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. I think this is like the 4th, 5th time that we've graphed this
Yeah.
regular parabola. This is the parent function. It's the most simple, basic parabola. And then I'm going to go in with a different color that's going to represent my function 1/3 x squared. So how do I go from x squared to 1/3 x squared?
Don't you multiply that by 1/3?
What do I have to multiply by 1/3?
Why?
The y. I'm multiplying the y by 1/3 because I'm multiplying x squared by 1/3. Well, what is x squared? It's my y values. Literally, negative 2 squared is 4. So I have to take every one of my squares of my x's and multiply by 1/3. So I'm going to go through, multiply all of these by
All your
1/3.
Y's by a third?
Yep.
Alright, cool.
Do we know what 4 times 1/3 is? Maybe. I'm just going to say 4 over 3, right? 4/3.
You have to do the mother graph every time.
No, but I'm doing it today. If it says to graph the parent function, you will. But on your quiz, no. Sure. Your quiz is exactly like the practice quiz. All I do, change numbers. Same form. The front page, I just changed the parabola. The back page, I think it's the first problem on the back page. It's in vertex form. I'm just changing the numbers. Same layout. Not changing any English word. I'm just changing the numbers. Okay, so 4 times 1/3 is 4/3. Can I write this as a mixed number? No, not improper fraction, mixed number. So this is 1 and?
1/3.
Yeah, 1 and 1/3. 1 and 1/3. So if I want to
Boy,
graph
wow.
this,
What?
4/3, how many times is 3 going to 4? 1 with 1 remainder. 1 and 1/3. So I'm going to graph this point. So I go to negative 2, comma, 1 and 1/3. So negative 2, and then I go up 1, and about 1/3 of the way to the next number, if this would work. Come on.
Why do you go? Oh, okay.
I think it's the pen. I think it's broken. No. Oh, there we go. So I'm right here. Because this is, right here is negative 2, and this is 1. Right here, this is 1, and then I go 1/3 up. So I'm going to 1 and 1/3. What is 1 times 1/3?
1/3.
Yeah, it's just 1/3. I'm not trying to trick you. So it's just 1/3.
Would that be negative 1/3? Oh, no. I have one.
I tried a new. Oh, wow. It popped up every time I tried to draw it. So I go to negative 1, and then go over to a third. So I'm a third of the way up. 0, 0, because 0 times a third is just 0. This is a third, and then this will be 1 and 1/3. Let's see. So go to 1/3, and then 1 and 1/3. So you see it's a lot wider. So you're literally vertically compressing it. You're pushing down on the arms. You're vertically compressing it. It's getting wider. Okay, what do you think 3x squared is going to look like? Multiply your y values by 3. So try to do B just like we did A. All right, so write out the parent points, multiply all the y values by 3, figure out is it going to be vertically compressed or vertically stretched. Give it a shot yourself. And notice we didn't put this in our calculator. You graphed 1/3 x squared without even actually doing, like, plugging in numbers into the equation. So.
Wait, but how do we figure out what numbers for the x?
What? So the x and y, all these, the blue ones I'm writing are from the parent graph. They're from the parent function.
Okay.
These are always the ones we use with just x squared, with the parent function x squared.
Wait, but I'm just confused. How did we get negative?
Wait, what the hell?
So those are the ones that we started with at the beginning of section 1. No, so beginning of section 4.7. So beginning at 4.7, we said, okay, what is the parent function? So we picked some numbers and we plugged them in. Did you watch the screencast of it?
I watched part of it. But
Okay.
Yeah, I got you.
So x squared has a vertex of 0, and then you pick the numbers that are around it.
Wait, hold on, quick. Can you just wait a second? Because I'm like kind of confused. Like I'm just still doing this, so I don't want to.
Yeah, we're going back to this. He's asking where these points come from. They come from the parent function, and we discussed the parent functions beginning of 4.7.
No, I know
Can
that.
we use those points for all of them?
So if it's, huh?
When you have the vertex, you don't use.
When I have the vertex. So what's the vertex of this graph? Negative b over 2a. What is my b?
0.
0. So what is negative 0 over 2 times 1? It's just 0. So this is my vertex, and then I have the numbers immediately around it.
Okay.
Yeah.
You just do that.
And 4.7 is on this one.
Yeah, it's 4.7 and 4.1. Okay, so I was trying to let you see both graphs at once, but I need to zoom in so it's not so bad. Oh my gosh. Come on. These guys have like 50 things open. Okay, how many solutions does this graph have? Do you remember what a solution is?
Yeah, it's one
When it
solution.
touches the x-axis, it has one solution. It only touches the x-axis once. What if my graph looked like this?
2 solutions.
2 solutions. And lastly, what if I have a graph like that?
No solution.
No solution. It doesn't touch the x-axis. Okay, cool. You guys are aware of solutions. Cool. So let's go ahead and let's plot 3x squared. So I just go through and multiply all my y values by 3. 12 is, I already have my x squared. I'm taking 3 times whatever my x value was squared. Well, secretly, guess what? My x value is negative 2. I already squared it. It's equal to 4. So I'm taking my x value squared, 4 times 3. Yes, this is great because I don't have to like plug in random numbers to like, and then square them and then multiply by 3. I already have half it figured out. So we're transforming our graph. So I have 0, 0, 1, 3, 2, 12, that's up here. Negative 1, 3, and negative 2, 12. So it's much skinnier. You can say it's getting vertically stretched, right? It's kind of like if I take your arms and I start pulling, it's going to stretch them into thinner. Vertically stretched, it's getting thinner. Yeah, exactly, it's spaghetti.
Do you want us to graph the parent function on the quiz?
So I've already answered this question. You don't have to. I'm not expecting it. The reason I'm having you graph the parent function right now is to drill into your brain the points, and
No.
drill into your brain what the parent function is.
And that would be.
And then if we had gone to this point last time, I wouldn't have graphed the parent function. This is just a way to review.
This would be vertically stretched, yeah.
This is vertically stretched because it's getting thinner. Vertically stretched. It's kind of like if you have a bunch of Play-Doh and I'm pulling on it, it's going to get. So I have my parabola, and if I'm like pulling up, like I'm getting thinner. My parabola is getting skinnier. It's getting vertically stretched. Vertically stretched. It's getting thinner. So without graphing, describe how each graph is related to the parent graph f of x equals x squared. So literally, how is this graph in A different than just the plain x squared? So there's a couple things going on. First, I see I have this negative in front. What does the negative in front? Flipped. And it's called a reflection. Okay, we understand. Reflection. Negative in front, it reflects across the x-axis, aka it just faces down. So the negative means we have a reflection, and it is going to face down, where our normal faces up. What about this next one? Is this have a reflection? No, there's no negative, so I don't have to talk about reflection at all because it's going to face up. I mean, I could write this just because I don't want you guys to. Oh my gosh. This is literally the dial-up internet of the 1900s. This is horrible. It's so slow.
So no reflection.
Reflection? None. My graph faces up, so it actually is not reflecting. Okay, now let's talk about the easier part. What is this -3 doing?
It's moving it downward.
Moving it down, and it's called a translation. Translation, you're just sliding it. Our translation is down by 3. Do you want to finish this graph, or do you want to talk about the translation of the second one? I'm trying to see which is easiest for you. Finish this one? Okay, perfect. And lastly, what is the 2 doing here?
Shifting it to the right.
It's a dilation. It's in front of x squared.
Vertical stretch.
Bingo, vertical stretch. Yeah.
So it's below 1, it's vertical stretch.
So this is 2. So the negative, so I'm only talking about the number, not the negative. The negative reflects it. Even if I have a negative 0.5, right, negative a half, the half part, I'm only looking at the number part. The negative just talks about flipping. The number itself is the
So
determines.
only with 1 or a fraction is it vertically.
So the definition is if 0 is less than absolute value of A, which is less than 1, aka if your number is between 0 and 1, I don't care if it's negative or not when I'm talking about the vertical stretch or compression. Then all the negative does is reflect it. That's why I have this absolute value symbol here. A is the coefficient in front of x squared. So I'm looking at the number in front of x squared. All right, is 0 less than 2 less than 1? No. So I know it's not going to get wider. It will get thinner. It's going to be vertically stretched. Okay. So what about this second one?
I got this.
Okay.
So
Wait.
Let's go.
Shh, wait. Okay. The 2 in front causes it to have a vertical stretch. You're multiplying all the y values by 2, so you're stretching it out vertically.
It's negative.
The negative, all the negative does is now flip it down and stretch it. Yeah, so the negative, all the negative does is flip it.
And the square has nothing to do with it.
It's just talking about a parabola being, it's just a parabola, that's my base. I could literally have -2 times absolute value of x minus 3. Did not mean to move that. So imagine I would have a graph like this. It would just be the absolute value flipped, and the slopes of each would be 2 instead. It's like, yeah, okay. Okay. Are you talking about the next problem? Questions about this one? Okay.
I have a question about
Yeah.
Is there going to be something like this on the
Look at your practice quiz. Look at your practice quiz. I told you I'm making the actual quiz literally changing number. That's all I'm doing, changing numbers. Look at your practice quiz. Okay, yes.
What happens if it's 1?
Then there's no dilation. If it's 1 in front versus -1, the negative flips it. It's when you have numbers other than 1. 2 makes it thinner, 1/2 makes it wider. Yep. Okay, my second one.
I think I know it.
All right, Felix.
I don't have it back. Alright, so the +1 is a translation up of 1. Yeah.
Okay.
So you're going to go up 1. The 4 is a vertical stretch. And the 2 in the parentheses is a translation of left 2, right?
Left by 2, yeah.
That's it.
Up by 1 and left by 2. So notice this +2 is inside the parenthesis. If it's inside the parentheses, inside the absolute value, it's your horizontal. If it's outside, like the +1, it's going to be vertical. If you're multiplying in front has the coefficient, like this 4, what does the 4 do? Done?
It's kind of off topic, but I think Jacob to the office.
Yeah, that's fine. Okay. So what does this 4 in front do? Not in front of x squared. The number in front of x squared. Yeah. Did he not go to the office before?
Basketball and he was playing.
Okay, so let's talk about the dilation here. So the 4 in front, what does the 4 do?
Oh, it makes
Dilates
it,
it vertically stretched.
So the 4 in front causes it to be thinner.
Yes.
It's going to be vertically stretched. Okay, awesome. Do you want to follow along, take notes?
What?
Do you want to follow along, take notes?
I am.
So if I come over to your paper, I'm going to see the graphs
No,
and writing.
okay,
I don't have to
will
walk
not.
over, I see it. Okay.
I will not.
Because the expectation for participation is you're following along, taking notes.
Wait. What's dilation?
That's the thing we just did.
It's literally the thing we
Oh,
just
I
did.
just did vertical stretch.
Did you
That
say
was-
something?
Are they making sure like he's gonna go to the
Yes,
doctor?
he has to go to the ER.
Wait, did he take him to the office?
Yeah, he's just like sitting there. No, it's
All right, f of x equals.
You're way too into it.
All right, guys, so let's do this. I really want to get through your quiz today, your practice quiz. So this is vertex form. I will write this on the board for you.
Wait, will that be on the quiz? Are the formulas on the quiz?
What did I just say?
You'll write it on the board.
I'll write this on the board.
Oh, for the quiz. I thought you were just gonna say that
I'll
right
write
now.
this on the board for the quiz.
Okay, perfect. Thank you.
And I will write ax squared plus bx plus c, f of x equals this. So this is the quadratic form, this is vertex form.
Okay, cool.
I'm not going to write vertex form, blah. I'll write f of x equals ax minus
And then
h
you write
squared plus...
vertex form now.
What did I just say? Felix, literally, 2 seconds. I will write the equation, but I won't label that it's vertex. Okay.
But okay, real quick. Also, instead of writing dilation, can I just write vertical stretch?
That's
We
fine.
have to know what it classifies.
A vertical stretch?
So
No, classifies under dilation.
But it's a vertical
check this out. Standard form, this is the last page of your notes. Vertex form, factored form. Check it out. Vertex form, literally h and k, that's your x and y of your vertex. You can find the vertex from standard form by doing negative b over 2a. I just thought I'd show you, this is the last page of your notes. I have a summary for you. That way, if you grab your notes packet, the front and the back are literally like summaries for you. That's great. Okay. So, vertex form. This should hopefully be semi-review because I introduced this to you before when we were in chapter 2 with absolute value. So A deals with the reflection. So the number in front of A If it's positive, your graph's going up. If it's negative, it's reflected. That's what right here is showing you. If A is absolute value of greater than 1, it's going to be stretched vertically. Meaning, look at the red one. The red one is stretched vertically. It's much thinner than the parent function, which is blue. If it is between 0 and 1, we say it's compressed vertically. It's being widened out. So that's the A. That's what's in front on your vertex form. Now the H is the horizontal translation. So notice it's x minus h, which is why it's opposite what you think. Because if you put in a positive number like 2, right? If I put in a positive number like 2, you would get, oh, like x minus 2. Because you put in a positive h. So that would be a shift to the right by 2. Imagine if you put in a negative number. What is subtracting a negative? Adding. That's why the horizontal is always opposite what you think, because vertex form is x minus h. So you're subtracting whatever your horizontal shift is. So if I would put in x minus a negative h, well, that would just be x plus 2 squared, and that would be what this guy is right here. So it's dealing with horizontal translation. It's opposite of the way you think. H is just the vertex form. This H is your left and right horizontal. The K is at the end. It's how much goes up and down. It's your vertical. Okay, this is just a review of what we already went over. So graph the parent function and then use the transformations to graph the function. So if you look at your practice quiz, not the front page, but the first one on the back, this is exactly how you would do the first one on the back page. It's in vertex form.
Practice test, not practice.
What are you talking about?
Mine says practice test.
Can I see?
I know.
You gave us both.
I gave you both already?
I don't know.
You have the practice test on the first day.
Blessed.
I mean, I
Okay.
didn't get to try for
I didn't get the practice test.
You should have a practice quiz as well. So if you don't have the practice test, I'll give it to you now. I mean, you have a month.
I don't have one.
Cool. Literally, the people who were here the first day.
Yeah.
Wait, where are those?
Thank you. Oh, I got what?
Where are those from? I was wrong.
Practice test?
Test?
What? This is notes.
Oh, I thought you said it was a practice.
Look at practice test.
Oh, okay. What page is this?
All I'm showing you is how to do the practice quiz. I think you were going to.
Oh.
So if you look at number 5 on the practice quiz.
What page is next?
Look at number 5 on the practice quiz. Look how similar it is to the ones we're about to graph. I'm showing you how to do this problem. Showing you how to do this one. The front one, you solve the way we did 4.1. This back one, the top, you solve how we did right now. Okay, I don't know how to be more clear with what I'm trying to do. No clue how to be more clear. Okay, so vertex form literally tells you the location of the vertex. So it's going to be y is equal to a times x minus, oh my gosh, come on. Load. Okay, so vertex form is y equals a times x minus h squared plus k. This will be written on the board for you, just like this. It doesn't say vertex form by it, but there's two things. There's two ways to write it. This is vertex form. No. I am showing you number 5 on the practice quiz. You would do it just like how we're about to graph it. So we're doing notes, but I had you pull out the practice quiz so you could see like, oh, this is the same form. I'm going to graph it the same way we're doing this one.
Okay.
Okay. So our vertex is at h comma k. So wait, literally how much you're shifting horizontal and vertical, that is where your vertex is located, as long as it's in vertex form. What?
K stands for vertical.
K is your vertical shift. So what is my h here? How much am I shifting horizontal? 2. Positive or to the right? Left or right to the right? So I see h is 2. How much am I shifting vertically? Down 5. So k is equal to -5. My vertex is at 2 comma -5. So that's, wait, okay. Please raise your hand. One question at a time. I can't. All right, let's do tall, then done. Tall?
Okay, my question was I don't see what
Okay. Is your phone over there? That's what I assumed. I saw you texting earlier. Just don't have your phone. I've asked you like 50 times. I'm done asking you. I'm just going to mark you down every time you're texting. Okay. So I'm going to start out with what we've been doing so far. The xy coordinates of my parent function. So what are the xy coordinates of my parent function?
-2.
-1, 0, 1, 2. Do we know what these are squared?
4.
4, 1, 0, 1, 4. And we said we have a horizontal shift to the right by 2. So I'm going to add 2 to all of my x's.
But I thought we multiplied the 1.
What?
And this is for the.
This is,
the.
I have a horizontal shift of 2 to the right. So all of my x's, what used to be at x equals 0 is now at x equals 2. So I'm adding 2 to all my x's, and then I'm going to subtract 5 to all my y's, and I'll have my new points to graph.
But why is that different? Like last time we multiplied.
We multiplied because I had a coefficient. I don't have a coefficient here.
Oh,
What's the, ready, what's the number in front? There's no number in front here.
Why is it a -2? Why is it a +2, not -2?
Because, so the x minus 2 inside means a horizontal shift right by 2, which is positive.
It's about the number in front of the negative. Right.
So when you do horizontal, it's always opposite what you think. You see x minus 2, you think negative, jk, it's going positive. It's opposite what you think. So I'm going to the right by 2. So a number used to be at x equals 0 is now 2 to the right, which is now at 2.
If it's x plus 2,
You would subtract 2. So my new points are going to be 0, -1. So 0, -1. I'm going to have, let's see, 1, comma, -4, right? 1, comma, -4.
2, -5.
2, -5. Wait, this is what I said the vertex was.
No way.
Are we surprised?
No way.
No.
Oh, holy
3, -4, 3, comma, -4.
4,
4,
-1.
-1. So did I have to plug in numbers and calculate every single one of these x values? Do I have to plug it back into the function and be like, okay, what is 2 minus 2? 0. Okay, 0 squared, 0, minus 5, -5. No, we can do addition, subtraction. That's doable. And
Wait, but why
hold on, pause. Okay, ready? So tomorrow is your quiz. It says no calculator. What I care about is graphing. I do not want you to use a graphing calculator. If you have a 4-function calculator, you can use it.
You know I got that.
A 4-function calculator
Wait,
looks like this.
so wait, you don't want us to use this?
No.
What do
You know why? You know why? Because I sit here in class and I watch people put in their calculator and then go, oh, point. I don't care if your calculator knows how to do it. I'm testing if you know how to graph. So on your quiz, because we're using it for the calculator sections, we use it for quick polls. We use it to do calculator skills. So almost every day we use it in class. Okay. On your quiz, you may use a 4-function calculator because I don't want you to miss the. Wait, what was that?
Easy multiplication.
What? Oh, it was homework I found. I was just saving so I don't lose them again.
Smart. Okay, so what you can do, I have a couple of these. I don't want you to make an easy calculation error. You can use a 4-function calculator. As long as it can't graph, you can use it. Yes?
Check your graphs. You just plug in the
Sure. So, you know where the vertex is? Like, am I surprised? This is the vertex, it's the lowest point. Like, cool. So I found the vertex with vertex form, and then I found my points. I see the vertex matches where it should be. What's the, is this graph going to face up or down? Up, because there's not a negative in front. A negative would mean it's facing down. So, you check it. There's a couple of different ways to check it. Are you facing up? Check, you did that. Are you at the right vertex? Cool. How many solutions does this graph have? 2, because it touches the x-axis twice. All right, let's try What?
We solved one on the quiz.
Wait, what'd you say?
We solved the
Can
one
we
on the
solve the
quiz.
one on the quiz? Let's do B, and then we're gonna sit up. We're gonna do B, and then we'll do this example right here.
Alright.
So let's solve B. So without graphing, what's this roughly gonna look like?
It's gonna be
It's gonna be
upside down,
reflection.
and it's gonna be up
Bro,
four.
I don't even
And then
know
to the
where
left.
Good. So you have an idea of what it's gonna look like. This is you double checking. So you know it's going to be flipped.
Upside down.
Yep, it's going to be reflected. It's going to be flipped. It's going to point upside down. And you know the vertex is going to be at -1, 4. Because I'm going left by 1, and I'm going up by 4. So you know there's going to be a point at -1, 4, and then the graph's going down. You already know what it's going to look like. So let's plug in, let's list out our parent points, our parent function points. So notice when you're in vertex form, this is definitely the easiest way to do it. So let me plug in my points, -2, -1, 0, 1, 2. 4, 1, 0, 1, 4. It's the same every time. If you forget, just square. -2 squared is 4. Top of page 14. So the first thing I want to do is show I go left by 1. So I must subtract 1 from all of my x's. So question, am I going to multiply by -1 before or after I add 4? So notice I have my x plus 1 squared, right? So it's whatever my x value was squared, multiplied by -1, then add 4. So I have to go through and multiply by -1, and then I can add 4.
Wait, why do you have to multiply by negative? Oh, okay.
Would you like me to eat some more?
No, I have water.
Why?
Thanks though. Appreciate it.
Wait, where the four? I see the four. The four, but where is it?
Because I have to flip it before I shift it up by 4. I have to flip it before I can shift it up. Yeah? That's why we have to multiply by -1 before we add 4. Because I have my parabola. I need to flip it upside down to a frowny face before I can move it up.
Why can't you do that after you?
Because that's going to be a much different graph. No. Because the order of operations, you're multiplying x squared. You're multiplying this squared by -1 before you add it. Order of operations, you have to multiply before you add. Okay, -4 plus 4 is 0. -1 plus 4 is 3.
So it's
0, 4, 3, and 0.
0. Wait.
So I have -3, 0. -2, 3. I'm just reading off my points that I have over here. -3, 0. -2, 3. -1, 4. 0, 3, 1, 0.
And that's what we got, yeah?
Yep. So does this match what we thought? Is it facing down? Yup. Look, where's my vertex? -1, 4, right? Our vertex is -1, 4, like we thought. Cool. It matches what we thought it'd be. So notice I didn't take 2, plug it into the whole equation, right? 2 plus 1 is 3, 3 squared is 9, times -1 is -9, plus 4 is -5, like, whatever.
Crazy, right?
Okay, cool. So, we're going to do this last example. Here we go. To determine the equation of a function based on its graph, it's possible to use the vertex and a point on the parabola.
I got the second.
So, write an equation vertex form of the following parabola. This is the last question on the quiz. 100%. It will be the last question on the quiz. It's on the. No. This is just like the last question on the practice quiz, which is going to be just like the actual question on the quiz. All I'm doing is changing the numbers. Same wording. So if you look at the number 7 of your quiz, write an equation in vertex form for a parabola with vertex blank and passes through blank. Write an equation in vertex form for the following parabola. So I give you the vertex and I give you a point. So, and it has to be in vertex form. So on the board, I will write y equals a times x minus h squared plus k. My vertex is literally, my vertex is h comma k. My vertex here is 3 comma 0. So I can plug in 3 for h. I can plug in 2 for k.
I was literally gonna do that.
Do I have one other point? I don't know what a is, but I can solve for it. My other point I'm given is -1, comma 2. So I'm going to use that as my x and my y to solve for what a would be, so then I could actually find the equation in vertex
Are
form.
you gonna put like the H, that same thing, like HK for vertex and like all the formulas, like the B over.
The two things I'm going to be writing on the board are standard form and the vertex form. This is what I'm putting on the board.
Did you teach us how to switch one to the other?
No.
How are you gonna teach us that?
Eventually, but you don't need it for the quiz. Either your parabola, I give it to you in vertex form, and you plot it the way we've been doing, or I give it to you in standard form, and you do -b over 2a, you find your vertex, and you have the numbers next to it.
And you do like the T chart thing, right?
Yeah, it's like I give you some rows to do it. Okay, so I'm using this other point, -1, -2, so my x value is -1, my y value is -2. Because I have to find a. Before I can write a general equation, I have to find a. Right? Because if I would just plug in right now, I have y equals a times x minus 3 squared plus 2. Because I plugged in h and I plugged in k. I have to solve for a's before I can box my answer that I found an equation. So, okay.
X equals -1, y equals 2.
So I plugged in h and k, my vertex. Problem is, I'm supposed to write an equation in vertex form. I don't have a value for a, but I have another xy coordinate. I can plug it in, solve for a, and then write my equation. I have to solve for what a is going to be. Solve for a. So I set y is -2. A, I don't know. I'm having my x be -1 minus my h, which is 3, squared plus my k. So I'm plugging all 4 of these values into the vertex form because I have to solve for this mysterious a.
Does it matter which one of the two the points you use?
Yes, yes. This is vertex. You have to plug the vertex into h and k.
Alright, so then you do the square root of -1 and -3.
Not quite. What?
Do you do the other ones that aren't the vertexes that swap?
Yes. This is why I did the other points x and y. So -1 minus 3 is -4 squared plus 2. So this is -2 equals positive 16. So 16a plus 2. And now it's just a game of getting a by itself. -4/16 is a. What is -4/16 equal to? -1/4. Now that I have that, I have everything I need. I have h and k, which is my vertex. I have a. Plug it into vertex form. Plug it into vertex form. This is your answer. Your answer is an equation in vertex form. So what we can do is, like the other two examples up above are just more graphing. I'd like to go over the practice quiz. So we have our practice quiz out. Does anyone need a copy right now?
I did a photo on Instagram.
Sure. Yep. First one to raise your hand, you get it.
Oh, it's sort of.
So, all I'm doing, you can bring a 4-function calculator. I'll try to bring some, like, in case I don't want the reason you miss points to be like little adding errors. Well, I don't want you to miss points at all, but like it shouldn't be an adding error, right? I don't want this to be the reason you miss points. Really want to know, can you graph? I'm not testing if you can add or subtract. I just want to know, can you graph? Okay. So, practice, let's see. All right.
I have.
What the heck?
And Felix.
Oh yeah, that's me.
And on your
Why are
Twitch,
they
you
getting
have They spelled my name wrong.
Okay. I think we can go through the whole thing before the end of class if we focus. Okay, so find the vertex, aka the x and y coordinate. So to find the x of the vertex, negative b over 2a, a is 1, b is 6, and c is negative 1. So it's going to be negative 6 over 2, which is negative 3. To find the y coordinate, I have to plug negative 3 back into the equation.
Are you putting x equals negative b over za?
On the board? No.
It's a
2
two.
eggs.
No, I'm not.
2 eggs is the.
Oh, yeah. Okay.
9 minus 18 minus 1. What do you get?
You get negative. Oh no, is that wrong? Oh wait, I.
9 minus 18 is negative 9 minus 1 is negative 10.
Oh, I was right.
So it's negative 3 comma negative 10. Okay, state the axis of symmetry. It's literally the x of your vertex. It's the x of your vertex, negative 3. Okay, find the y-intercept.
-1, -10.
How do you find the y-intercept?
Plug in x is 0 for x.
Plug in 0 for x. Plug in 0 for x.
0 for x.
-1.
No.
Yes. Okay. Axis of symmetry, it is literally the same as your vertex, negative 3. Find the y-intercept, plug in x equals 0. So you have 0 squared plus 6 times 0 minus 1. So it's just going to be 0 comma negative 1. That's the y-intercept.
Oh, you plug the y in.
Plug.
You just do y equals -1. You want to put it in the.
It must be a coordinate.
Oh yeah.
The intercepts are coordinates. You must have x comma y. And whenever you write a coordinate, it's always x first, then y.
For axis of symmetry, we do -3, 0.
Axis symmetry, axis is a line, so it's x equals negative 3.
So is this always what x is?
Yeah, the axis symmetry is always your vertex, your x or your vertex. So, literally, on your quiz, I'm going to change what the equation is. It's going to be the same questions. Same questions. Just change what the equation is. Okay. Graph the function. You may use a table of values. Remember to show the axis of symmetry. So, the axis of symmetry is at negative 3. So, I'm going to put this in the middle. And I know the value is negative 10. And you can say, see above. You don't have to redo all the work you already did.
Oh.
Wait. So I need the numbers next to negative 3.
-2 and -1.
And then I could do the ones. I want the ones right around my axis of symmetry, right around my vertex. So I'm doing the ones right next to it. Wait, x equals -1. Don't we know what the y is going to be? Look at the problem we just did. The y-intercept.
-1, -6.
That's it.
I thought, oh, my bad. I thought it was, my bad. I remembered the -1. Yeah. So we do have to plug in. I thought, my bad. So we have to plug in. So I have -1 squared.
You plug the x, so
Plus 6 times -1. Is this -1? -1.
Minus 1.
So I have 1 minus 6 minus 1. So it's just -6. -2 squared plus 6 times -2 minus 1. 4 minus 12 is -8 minus 1 is -9. And then wait, if this is the axis of symmetry, how do the numbers? They're the same. So guess what? If you draw your arrows like this, you don't have to re-show your work. Cool. Draw the arrows to show me you understand axis symmetry means the same on both sides. That is the work. You would just have to write. Look, 2 lines. Can you draw arrows? Yes, you can draw arrows. Now that I have those, plot them on your graph.
No, I have a question because I have one on the homework where it wasn't the same on the last one. How do we?
The axis of symmetry? It will be. If you're equal x's away from axis of symmetry, it'll be equal y's.
Oh, so if it's not equal.
Because notice I'm 1 above, 1 below have the same y. 2 below 3 and 2 above 3 have the same y values.
But what it was the last one,
So show me the specific one. Not at this moment. Perfect. Okay, so I'm going to go -3, comma -10, -2, comma -9, -4, comma -9, -1, comma -6. Once I have these, oops, make sure it's a parabola. I want you to show your axis of symmetry. The easiest way to do that, just draw a dashed little line.
That's it. You can ask us like minimum or maximum.
Well, my hint to you is I'm taking the practice quiz and I'm going to change the numbers. I will not change the English words. I will just change numbers. It will just be a different equation. That's it. How many solutions does this have? 2. Touches the x-axis twice. Right here and right here.
So could there even be more than 2 if it's not all the line?
No, literally your options are none, 1, or 2. Those are the only 3 answers possible.
All those things
No, no, parabolas. I'm only talking about parabolas. Come on, parabolas. All right, let's graph this. Wait, this is in vertex form.
It's a reflection.
Oh my gosh.
That sounded scary.
So, I have my x and my y. Oh my gosh, what the heck?
Wait, how many solutions did it have? 1?
2, because it crosses the x-axis twice. What?
Isn't this vertex form? Wait,
Oh,
Was it?
Yeah. Yep.
Okay. Thank you. Thank you very much.
All right, so I know it's going to be reflected down. Where's the vertex going to be? Where's the vertex located?
It's at 4, -6.
-4, -6, right? -4, -6, because it's going left by 4. Yes, Jesse? Down by 6. So I'm just going to put that dot on my graph because I know that should be my vertex. This is a very easy way to know you were graphing it correctly. I know where the vertex should be. I'll put the dot there. When I draw my graph, it should go through it. -4, comma -6. There. I know that's my vertex. Vertex form. And I know my graph's going to be pointing down. Okay. So let's find. So I'm going left by 4. So I subtract 4 from each of my x values. I'm sorry, you can't like read these numbers. Ugh. Okay. -4, -3, -2.
Is that -8 though?
Where? No. No. Okay. -6, -5, -4, -3, -2. Okay, so I have to reflect my y-axis before I subtract 6.
Oh, for real? So you gotta like minus down?
Yes, so I do the negative in front,
Yeah, that's what I was saying.
and then I subtract 6.
Wait, so if it reflects, you always have to switch the y's as well?
If it reflects, you put the negative in front of your y's.
Okay.
That's hella
Can I
confusing.
just like a really quick question? Like when I did it, I just waited to do the chart until I add. Do you need to see the other work before it, or if you see that, you'll know?
Did you? So what did you do? You subtracted 6 everywhere?
Yeah. Is that not the
Yeah,
that's what you got.
it's fine.
Is that fine if you just have the
Yeah,
final
because
chart?
since I'm not letting you use a graph calculator,
Yeah,
there's no way you can do it
there's no
besides
way,
this.
yeah.
So it's fine.
Okay, thank you.
That's plenty of work, and then that helps you.
Okay.
Okay, let's graph it. -6, comma -10. -5, 7. Shh. Shh. This is my graph. Wait, is it facing down? Yes. Is it going through my vertex? Yes. How many solutions?
0.
None, because it's not touching the x-axis at all. There's no solution. No solution. Okay.
Wait, hold up.
He's taking his own notes, so
Wow, that's good.
Are you proud of it?
That's solid.
Let's go. You're getting great on this.
So we've done most of the practice quiz in the last 10 minutes. This is great.
No way. We're Miss O'Brien, but it's only because like you're helping us.
I write.
Miss
Oh
O'Brien,
my god.
when I'm on the quiz or the test or whatever,
over.
I'm like, okay, I know this, I know this. And then it's like,
Hold on, you guys. I can't hear talk. We have 2 more minutes. We have 2 more minutes.
when you're helping class, like, it's like, I feel like I know it, and then I get to the quiz and like,
So you have to make sure to do your homework and go over the practice quiz.
I get trust.
So
thank you, Miss O'Brien. Oh, wait, are we done?
we have 2 more minutes. I'm gonna keep going through this. 2 more minutes. If you guys didn't pack up so early, we'd be done by now. So -b over 2a. What is my vertex?
Three. I'm
It's
guessing, I think.
gonna be, yeah, it's gonna be,
So it's at -3. And if I plug in -3, you get 0. Is this facing up or down?
It is facing up.
It's facing up. So wait, if I'm going up from here, how many solutions will I have?
isn't that 9?
1.
Isn't it 9?
9 minus 18 plus 9 is 0.
Oh, I forgot it's 18. That's out.
So your equation, it's gonna look like this. You would have 1 solution, and the last problem we have to go over would be the vertex form. You just use it like the last example we did that were actually in the notes, and that's the whole quiz. I'm not asking about min and max. This is your exact quiz. I'm going to change the numbers. That's it. Goodbye.